So we don't have enough people. That's right. So what I do, I will try. Because I would like to review what we covered in the experiment. So if we assume that we have group 1, 2, 3, 4, 5, and 6. So my plan was to do to ask group of 1 and 6 to work on the question number 1. These are the questions from your lab handout. Okay. But I will try to summarize. Okay, we don't do the group activity today. Okay, we will do because we don't have enough to do that in the class. So the dynamic of the card on an incline path. Good. So there were 3 questions, and we know how to graph. Okay. When we had a card, so let's say when there was a motion detector here, this is a motion detector, good, and this is a card. Okay, the object's moving toward to the motion detector, good. Speeding up or slowing down? It's slowing down. Slowing, when it's moving toward here, it's gonna be a slowing down. What is that velocity when you are moving toward to the motion detector? Your velocity is negative, good. So the velocity is negative because it is slowing down. Acceleration should be positive.
Positive.
Good. So, but when it's moving back, let me just draw here. When it's moving back, yes? There is a motion detector here. When it's moving back, what happened to the velocity? The velocity is going to be a speeding up. Good. A speeding up. What is the velocity? Positive. So because it's speeding up, acceleration is going to be positive as well. Okay. So if I draw the position versus time graph, what happened? Position versus time graph. Good. What happened? How the graph is going to look like? Do you remember? Perfect. Like this, yes? The first one, you start from a couple of meters away from the motion detector here. Good. You remember we had 4 graphs? You need to memorize those 4 graphs or analyze it. So this was the first part, yes? If I call this number 1 and the motion number 2, this is motion number 1. Why? Because the velocity is negative and acceleration is positive. Good? Concave up. What happened to the second part? Okay? So the velocity positive and the concave is up, acceleration positive. So here, if I write it down, the velocity is negative, acceleration positive. Here, the velocity is positive and acceleration is positive. Good? So we already discussed about this graph more. So, okay, was the acceleration constant or changing? Nope. Acceleration was constant or changing. When you graph the acceleration versus time graph, yes? This is the velocity versus time is going to be something like this, yes? Okay? And the acceleration versus time, the slope of velocity versus time is the acceleration. Good? You see the velocity graph? You have seen this velocity of graph. The slope of the velocity versus time is the acceleration. What is the slope of this line? Positive and constant number. It is a constant. The acceleration is not changing. Velocity is changing. Okay? Good. So the acceleration is going to be positive. So is a constant. Was there any point the motion where the velocity was 0? Yes. Good. Because it's move up, stop, yes, and then move back. It's slow down, and you can just see here. This is a tangent line. The slope of tangent line in the position versus time is the velocity. The slope of this tangent line is 0. Good. This is where we have the object is stopped. Good? Yes? When it's reach to motion detector. So was there any point in the motion where the acceleration was 0? Look at the graph of acceleration versus time. Is the acceleration 0? No. Acceleration is always constant and positive for this situation. Okay, next one. Oscillating object. Do you remember what graph did you see? What graph did you see for position versus time? This is the position versus time. Okay, there was a graph something like this, yes? You see this graph. If I want to graph the position versus time, sorry, velocity versus time, what do I do? How the velocity versus time is going to look like? It's going to be the same thing, yes? Changing velocity. The velocity is always changing, but I know that at the peak here, because this is the slope of tangent line, yes? The velocity here is 0. Velocity at the peak, 0. Because the slope of tangent line is 0. Good? Here, the velocity is 0. 0. 0. 0. 0 and 0. But before this 0, what was the slope? Positive. After this, what is the slope? Negative. Perfect. Here is 0. Before the slope, before the 0, what is the slope? What is the slope of tangent line? Negative, and is positive. And so how is going to look like? So you can say, you know, this is positive velocity, and then is it still negative, and then becomes 0, yes? It is positive and then becomes 0. Again, negative becomes 0, positive 0, negative 0, positive 0, negative 0. Good? You see, the velocity is kind of like a sine and cosine function, yeah? And is changing velocity. If you want to do the acceleration, okay, the acceleration is going to be the changing acceleration as well. The slope of velocity versus time give you acceleration. So again, where the acceleration is 0 here. Again at the peak, yes? Peak, acceleration 0, acceleration 0. Right. Acceleration 0, acceleration 0, and there is the acceleration 0 on the bottom as well. Acceleration 0. If you graph the acceleration versus time, what is the slope of acceleration before 0, after 0? Negative, yes? So it means that it starts from here. It start from here, negative 0, positive 0, negative 0, positive 0, negative 0. Good? Okay, now we can answer this question. Was the acceleration constant or changing? Perfect. How can you tell? Because the velocity was changing, okay? It's the sine and cosine function. Good? And the acceleration is going to be cosine. Was there any point in the motion where the velocity was 0? You remember where the velocity was 0? Here the velocity is 0. Good? You know, when it's moving up and down, when it go up, stop and change its direction. Good? When it go down, stop and change its direction. Okay? The spring was moving up and down. Okay, the velocity at those points was 0, but when the velocity was 0 at this point, see, the acceleration had its maximum. Good? Yes, the velocity on the top and the bottom when the spring was moving up and down, let's say, spring was moving up and down, good? See, up and down. When it's here, the velocity becomes 0, yes? When it's on the top, the velocity becomes 0. But the acceleration at point are maximum. Why? Stop, but there is a force that brings the object to the motion again. Yes? Change direction, velocity becomes 0, but there is a force that's moving it upward. There is a force moving it downward. Good? That's why the acceleration, when the velocity is 0, see, when the velocity, yeah, we should start from 0. I made a mistake here. Let me just erase this. Acceleration, good. When the velocity was 0, yes, the slope of tangent line here, the slope of tangent line here is 0. But it's after 0, it's negative. Good, so it's going to be something like this. So when the velocity is 0, we will have, see here, when the velocity is 0, we will have maximum acceleration. When the velocity here is 0, we will have maximum acceleration. Good? Maximum force bringing object to the motion. It means that force and acceleration are directly related to each other. Okay? So, yes, we just explained that. We have the acceleration. We know where the acceleration is 0. Okay, acceleration in the middle. Okay, in the middle of the motion, the acceleration is 0. Middle of the motion. What does it mean, middle of the motion? Because let's say this is moving up and down, yes? In the middle, not up, not down, in the middle, here, the velocity becomes max. The velocity here is 0, here is 0. The acceleration in the middle will have its maximum velocity because it's speeding up and slowing down. It's speeding up and slowing down. Good? So, was the mass where the mass where was the mass when the acceleration was greatest? Okay, we just explained on the top and the bottom. The acceleration is the greatest. Okay, the next one. This one is going to be exactly like the incline path, yes? So if you draw the ball, if you drop the ball, okay, throw the ball on the air, what happens when it's going up? It's slowing down, yes? When it's moving down, it's going to be speeding. So what would be the velocity here? When it's moving up, velocity is positive, but because it is slowing down, acceleration is negative. Speeding up, when it's moving down, the velocity is negative and acceleration should be negative as well. Good? So at these 2 points, the acceleration is always negative. It means that your concave is down. Good? If I draw position versus time, position versus time, good? So what happened? The position is start from the origin. Let's say here is the origin, is start from the origin, become like this, yes? In the first motion when it's going up, and then like that, yep? The velocity is positive, acceleration negative, velocity negative, acceleration positive. What happened to the velocity versus time? What is the velocity? How we can draw the velocity? The velocity was positive first. It's become 0, yes? And then negative. And what is the acceleration here? Constant. And it's the gravitational acceleration. Again, if there is no air drag force. Good? So this acceleration is going to be negative. Okay, so negative, and it is negative g. Good? Was the acceleration constant or changing? Constant. Was there any point in the motion where the velocity was 0? Yes, when it's reached on the top, yes? Okay, Yes. Was there any point in the motion where the acceleration was 0? No. The acceleration in the motion, in the entire motion, the acceleration was constant and the gravitational acceleration. Okay, we are done. And have a good day.